Hello class. So yesterday we learned about three factors that affect the rate at which a reaction takes place. The first thing we learned about was concentration. The more concentrated, the more particles there are. Because there are more particles, they are going to collide more with one another. And because they collide more with one another, that's going to increase the rate at which a chemical reaction takes place. When you increase the temperature, the particles start moving faster. And because they're moving faster, they're going to bounce into one another more often. Because of this, they're going to cause a chemical reaction to take place, and the rate of a chemical reaction goes up because they're colliding more with one another. As the pressure goes up, the particles are colliding more with one another. Okay, they're closer together. They're bouncing off each other at a higher speed and a higher rate. Because of this, because of this increase in pressure, there's going to be an increase in the rate of a reaction. So again, all these factors, an increase in concentration, an increase in temperature, and an increase in pressure are all going to increase the rate of a chemical reaction. Now, the new thing that I want to talk about today is how could we speed up the rate at which something decomposes, right? We talked about French fries at the beginning of the unit. How can we speed up the rate at which a McDonald's burger or French fries decomposes? And one thing we haven't talked about is something called catalysts. And these are the new notes that you're going to be writing on the right side of your notebook. So go ahead and write catalyst, activation energy, and reaction coordinates on the right side of your notebook. Okay, so now that you're done with that, feel free to pause this if I'm going too quickly. The next thing I want to talk about is what are reaction coordinates. And as you guys know, your teacher loves graphs, tables, your teacher loves data. That's what science is. It's analyzing and creating data and making sense out of it. If you look at the screen, this graph shows the relationship between energy and time. So what is the time? What is happening with respect to time during a reaction? So if you look up here, A plus B, you start at 40 kilojoules. That is the energy that you start with. So these starting material, A plus B, they start at 40 kilojoules. As the reaction proceeds, you need more and more and more energy. Okay, so you're going to need more and more energy. And then up here on top of the hill, that's where the bonds start breaking and new bonds start forming. So this is the part where a chemical reaction actually takes place. And then you end up forming something new, C plus D. Okay, these are your products. So again, a reaction coordinate just shows the relationship between energy and time. So what is happening over time? Over time, you start off with a certain amount of energy. You need more energy to start a chemical reaction, and then the bonds break and new bonds form. And at the very end, you end up forming these products. Okay, so this is how a reaction coordinate looks like. Now, the next thing I want to talk about is something called activation energy. Every single reaction that occurs requires a certain amount of energy in order for a reaction to start. Okay, so you need a certain amount of energy in order for a reaction to proceed. Okay, this energy is called activation energy. Again, activation energy is the energy required to start a reaction. Okay, and if you look up here, there's an abbreviation for activation energy. It's E sub A. Okay, that's how we depict activation energy in chemistry, by using this EA. So if you don't want to use the whole word, you could just use this abbreviation. So if you look back at the previous slide, the activation energy would be shown by this arrow right here. So 40 all the way to 100, you would need 60 kilojoules of energy in order for this reaction to start. Okay, this is very important. So you start off with 40 and you end with 100. That is a difference of 60 kilojoules of energy. That is the amount of energy that you need in order for this chemical reaction to take place. Okay, every reaction needs activation energy. So what is a catalyst? And the video that we saw yesterday did a really good job explaining what a catalyst does. Okay, so let's go back to that last part of the video at 3 minutes and 50 seconds. Here we go. Cool. So the video the video talked about catalysts. Um, Catalyst is something that puts the molecules in the correct orientation, and they speed up the rate at which a reaction takes place because of that. Okay, again, a catalyst orients the it puts the molecules in the correct orientation, and that causes a chemical reaction to actually take place. Now, if you look up here, I told you guys, just a reminder, that the amount of energy that you start with and the amount of energy that you end up using up to start a chemical reaction, that is called the activation energy. So in this case, the activation energy would be 60, right? 40 minus 100 would be 60. So 60 kilojoules of energy is needed in order for this reaction to take place. So here's an example. Which coordinate has a lower activation energy? So you start drawing your arrows, right? From the very bottom all the way to the very top. Okay, so they should look like this. So A is your reactants, you start there, then you go all the way up to the hill, and that would be your that would be your activation energy, or the energy needed to start your chemical reaction. Okay, down here you start down here, and then you go all the way up the hill. That would be the activation energy, which is the energy needed to start a chemical reaction. Okay, so again, what are catalysts? A catalyst is a substance that speeds up the rate of a chemical reaction by lowering the activation energy. Okay, so if you are lowering the amount of energy needed to start a reaction, the reaction is going to happen at a faster rate. Okay, so how does this look like on a graph? Here are two different reactions. The first one right here is uncatalyzed. Okay, that means no catalyst is used. Because there are no catalysts, the activation energy is going to be large. It's going to require a larger amount of energy to start a chemical reaction. But down here in purple, you are using a catalyst. So because you're using a catalyst, the activation energy is going to go down. You're going to need less energy to start the chemical reaction. The reason why you need less energy is because the catalyst ends up orienting the molecules in the correct position, and that requires less energy. And because of that, the hill is going to look much smaller, and the reaction is going to proceed at a faster rate. Okay, so this is probably the most difficult concept, and it's this slide right here, understanding how catalysts work. Again, if you don't have a catalyst, the activation energy is going to be greater. Okay, you're not going to get help from a catalyst, therefore the molecules are going to have a hard time orienting themselves in the correct position to actually start a chemical reaction. But if you have a catalyst, very little energy is going to be needed to start the chemical reaction, because the catalyst is going to orient the molecules in the correct position, and that's going to start the chemical reaction at a faster rate. Okay, hopefully that made sense. If not, you could go back to maybe 7 minutes of this video and listen to it one more time, and that should do the trick. On the left side, on the right side of your notebook, again, on the right side of your notebook, you should have written all these notes. So you are not giving notes. You have to write them on your own this time. And on the left side of your notebook, I need you to summarize what was learned throughout this small podcast using those four words: accelerate, catalyst, activation energy, and reaction coordinate. So it'd be a good idea to actually draw a reaction coordinate and then um, explain how a catalyst plays a role and what an activation energy is and how you would accelerate the rate of a chemical reaction, which is the essential question for this podcast. And then at the very end of class, you guys are going to write an exit ticket. So make sure that you answer these questions on a half sheet of paper. These will be turned in at the end of class. Go ahead and put your name. Try not to get help from a neighbor. I want to see what you currently know at this point in time. So go ahead and draw a chemical reaction coordinate. Label the reactants, label the products, label the activation energy, and um, on the reaction coordinate that you drew, draw a slash line to represent how a catalyst would impact the rate of a chemical reaction. So it would be this slide right here. So go ahead and draw this and explain it to me. See if you could explain it to me. And if you can't, then go ahead and get help from me. Okay, so that's why I'm here. I'm here to help you. Okay, good luck.